The next question, we've got to find the region in the first quadrant bounded by the x-axis and the graphs of y equals log x and y equals 5 minus x as shown in this figure. Well, let's have a look. If we think about drawing our rectangles, notice that our rectangles to begin with are only bounded by y equals log x. I'm assuming that everybody knows that this must be y equals log x, and I'm going to call that y1. So let's put that in red here. So I'm going to change the color of my rectangle. Not a very good start to this, was it really? Let's change the color of that rectangle so it looks like this. But we've also got the function y equals 5 minus x. And I can call that y2. So my rectangles, which are going to be the sum, I'm going to add up these rectangles to make the area. They are simply bounded by y equals log x until a certain point. That certain point being here. I don't know what that number is yet, but after that my rectangles are simply going to be bounded by the green function, y equals 5 minus x. So the first thing we have to do is to use our calculators to find where these two functions meet each other. So we have to find the intersection of where log x is equal to 5 minus x. Use your calculators and you get the answer 3.6934414 something 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 something, and either write that number down in full or store it as A. And so now we can simply say that the area is the integral from, you'll be surprised the number of people who say 0. They're just so used to saying 0, and if you look very carefully at the graph, well, for a start, log x isn't defined at 0. This red graph will continue coming down if there's an asymptote on the y-axis. So it's not from 0, it's from 1 to a of log x dx. Please, whatever you do, don't work these out separately. Your calculator is really quite clever. So you can just say simply plus the integral from a. Well, we need to know this point, but I don't think anybody should have difficulty of finding where is y equals 5 minus x equal to 0. Of course, that must be when x equals 5. So it's from a to 5 of 5 minus x dx. And you can put all of that into one line of your calculator and you will arrive at the answer 2.9858 blah 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 blah, which to 3 decimal places is 2.986. But as I said on the previous little video, if you say 2.985, that will also get you full marks. So finally, a very similar problem. You again will notice that we've got f of x, which is y equals root x, and we've got g of x is 6 minus x. The first thing we have to do in this question is to find the area, and we're told that they actually intersect at the point 4, 2. So our rectangles, let me use a different color. First let me just, well, we got that as 4, that's all right. So we've got these rectangles here, which are only bounded by y equals f of x, and then we've got rectangles over here which are only bounded by g of x, which is 6 minus x. And so we can say that the area is going to be, let's write this down, it's the integral between 0 and 4 of root x dx plus the integral between 4 and 6 of 6 minus x dx. Okay, well, the integral of root x, x to the power of half, will be x to the power 3 over 2 times 2/3 between 0 and 4, plus, and what have we got here? 6x minus x squared over 2 between 4 and 6. Let's work these out, I hope, fairly quickly. So the first one will be 4 to the power 3 over 2. 4 to the power 3 over 2. Well, 4 to the power 1 over 2 is 2, so that will be cubed, which is 8. So 2 over 3 times 8 is 16 over 3. Minus 0, obviously, when you put 0 in, you get 0. Plus, now let's do this. You put in 6, and you get 36 minus 36 divided by 2, which is 18. Minus, put in 4, and you get 24 minus 4 squared over 2, which is 8. And so our answer is 16 over 3 plus, now 36 minus 18 is 18, minus 24 minus 8 is 16. So 18 minus 16 is 2, and therefore our answer is 16 over 3 plus 2, which is 22 over 3. One small point before we finish this is that the second part of this integral, when you were finding this area here, yes, this area corresponds to that integral there. But for people who are very quick thinking, they could have saved themselves a bit of time by simply saying, well, hang on a minute, Mr. West, this is a triangle. And we know that the area of the triangle is 1/2 times the base, which is 2, times the height, which is 2, and the answer is 2, which of course is what we got from this bit here. Now you might say, well, hang on, the previous question, you didn't do that. Well, no, I didn't, because although this would have been, it is technically possible, notice that the base is now 5 minus a, and a was at 3.69344414, whatever. And we'd also have to find the height with the intersection of those two as well. So it really wasn't a practical way to work out that answer, so therefore I didn't. But here, there's a nice easy way of getting the second part just by using simple geometry. Okay, that's the end of the homework.